So let's finish off the question now. In part F, we want to find out the global maximum of the function. So where do we have the highest value of the entire function, not just the local points. So what is important about global maximum and local maximum? You see, if we look on a graph, when we have a function that has limits from the left and from the right, in our case from -2 to 3, let's say the function would have something like this shape. It has a limit, and let's give some some examples. This is the value of x equals to 2, and this is the value when x equals to 5. You see, at this point our function is stationary. We're reaching a local maximum, so we have this peak, but it's not the highest value of the function on the graph, because the highest value of the function on the graph is over here, and this is an end point. This is where the domain of the function finishes. We take the values until 5. So actually f of 5 is the biggest value on the graph, and that's what we call the global max. So global max means the highest value on the entire graph, considering also the domain. But local max is just a point where the value is higher than the let's say neighbor values. If we look to the left and to the right of these points, we can see that the function has lower values. So when we have this local peak is a local max, but the absolute max, the global max, we have to look for the entire graph. Now in our question, we know that x equals to plus minus 1 are local minimums, so they're not interesting to us. They cannot be global maximums if they're already local minimum points, if they're already these values over here. The only option that we have is either this local max of x equals to 0 is going to be the highest, or our endpoints of -2 and 3. So what we have to do is check these 3 points. What is the value of the function when we have x equals to 0? Well, first of all, let's write the function once again, because we did not use it in a long time. What was it? It was x to the power 4 minus 2x squared. Well, x to the power of 4 minus 2x squared, that means we would have 0 to the power 4 minus 2 times 0 squared, and that's just 0. So the function has the value of 0 when x equals to 0. What happens when we check the endpoints? So maybe at the endpoints we're gonna have a global max. F of -2 is equal to -2 to the power of 4 minus 2 times -2 squared. -2 to the power of 4, that's 16, minus 2 times -2 squared is 4. 16 minus 2 times 4, that's just 16 minus 8, and it's equal to 8. And the last option is, what is the value of the function when x equals to 3? So f of 3 is equal to 3 to the power of 4 minus 2 times 3 squared. 3 to the power of 4, that's 81, minus 2 times 3 squared, that's 2 times 9, which is 18. 81 minus 18 is 63. And we can see indeed the highest value is 63. 63 is greater than 8, is greater than 0. So the global max, the highest point, is when when x equals to 3. And that would look something like that. Maybe when x equals to 0, it's not going to be exactly the same with these numbers, but if x was 0, we have a local maximum like here, but when x equals to 3, we have a global maximum of 63. That would be the graph behind it. Anyway, we are done with this question overall, and hope it helps.